Hello everyone, I welcome you all to this session on AWS tutorial. Today in this session, I'm going to give you a comprehensive overview of what AWS is, and we're going to confine ourselves to basically what an AWS solutions architect should know. Right? There are 100 plus services in AWS. It's very difficult to know all the services, and I'm sure there's no AWS professional out there who knows all the AWS services which are offered by Amazon. Right? So without wasting any time, guys, let's go ahead and start with the agenda to understand what all we'll be covering today. So guys, we're going to follow a top-down approach. We're going to start with an introduction to cloud computing. Then we're going to understand the various cloud models that are available in cloud computing on which the companies operate. After that, I'm going to introduce you to what AWS is and how it fits in the storyline, where we are starting talking about cloud computing, then talking about cloud models, and then talking about AWS. It will all be clear when we reach this particular point. After that, I'm going to introduce you guys to the various domains and services that AWS has to offer, based on which companies are using AWS and have made AWS the #1 cloud provider in the world. Right? After that, I'm going to show you guys an application which basically resides on my local computer. I'm going to show you guys how you can architect its infrastructure on AWS after this session, and I'm sure it'll be helpful to you. Now guys, this session is a live session, so I want you guys to be as interactive as possible so that it will benefit both of us, right? So if you have any questions during the session, please comment it in the chat box and I'd be happy to answer it for you. Right? So just a quick check, guys. Are we all clear with the agenda that I've just discussed? If yes, please put a yes in your chat box and we'll move further. All right. So I can say Shubham is clear. So is Akanksha, Roshan. All right, guys. So I see that all of you guys have given me a yes. So let's go ahead and start with the session with the first topic, which is introduction to cloud computing. So what is cloud computing exactly? Let's understand that as we move along. So guys, cloud computing is nothing but the use of remote servers on the internet to do a particular task, right? Now you would ask, like, why do we need to connect to remote computers when I can do everything on my personal computer? Now imagine if you have an application which requires a lot of processing, right? So what will you do? Will you buy a server which has a lot of processing power, put your application over there, and then see how your application is functioning? Or if I give you one more option, that you can rent a server from a cloud provider and basically do a RDP or an SSH into that, put your application over there and see the working of that application, how it runs. And I also tell you that the moment you are done with the server, you can just give it back to me and I'll charge you only for the time that you used it. On top of that, what if I tell you that it's as cheap as $0.0005 per hour? Isn't that amazing? And that is exactly what cloud computing is all about, guys. So cloud computing, for a beginner, it's nothing but the use of remote servers for a personal needs, right? And rather than using our own computers, or rather than buying servers of our own, I just want to rent a server on a cloud and I will pay them accordingly to the time that I have used, and the prices are as low as the figure that I just told you, right? So this is what cloud computing is, guys. Now you would wonder how it actually came into the picture, right? So let's go ahead and understand that. All right, guys, so let's take an example to understand this. Imagine you're a developer and you created your first app, which you think is going to be a hit, right? So how do you make this app available to the world, right? Or how do you make this app or website available to the world? So what do? You buy some servers and you put that application over there, right? And just putting your application on the servers would not do it. You'll have to connect it to the internet. And once you connect it to the internet, that is when people start to come on your application, come on your website and start to use it. All right. So this is how typically work used to be done. Now I want to take your focus onto certain things that I just said when I was explaining you this example. First of all, I will have to buy these servers. Right? And guys, servers are not cheap. They're very expensive, and buying a stack of servers will already cost you a lot of money. And you're not even sure whether your app will be a hit or not, right? You've just created your app and you want to try it out, and you put it on some servers, and because you want to make it production grade, obviously you'll have to buy a stack of servers, which is going to cost you a lot. right? Second thing is you will have to configure everything manually. If these servers have to be connected to the internet, you will have to do the connections, to this servers manually. You'll have to set up a static IP address. So you'll have to contact your ISP and say that, I need a static IP address for my servers so that people can just go to one particular address and they can visit it. After that, you again have to buy a domain. Let's say if you go to Intellipaat.com, you see the website, right? So what is happening? Intellipaat.com in the backend, the domain is getting converted into an IP address by a DNS server. And then that IP address is basically pointing to these servers, right? So you will have to buy a domain, you will have to point that domain to these servers, and that's how it used to work, right? And obviously, if you have these servers, you'll have to hire a team also who's gonna manage these servers in case the number of users increase. You'll have to increase the number of servers, etc., etc. There are a lot of things that you'll have to do. And because of these things, there were some problems. And because we wanted to overcome these problems, we use cloud computing. Right now, like I said, you were using this kind of an architecture before. Now let's see if we don't use this kind of an architecture and I just use cloud computing, what is going to be the difference? The difference will be that I created my application. Next thing is I'll go to AWS, I'll launch a stack of servers, I'll put my application over there. AWS automatically gives me a static IP address. It has a service to basically give me a domain name as well. I would just configure my domain name to connect to this IP address and I'm done, right? It's so much ease that I don't have to hire a team to manage my servers because AWS says whatever servers you want to launch, I'm going to handle it for you. Not AWS, it's in fact any cloud provider for that matter. All the servers are managed by them. All the hardware upgradations are managed by them. Everything is managed by the cloud provider. And that is why cloud computing model itself is such a big hit, right? So what are the advantages? The first thing is that there is little or no investment. So I don't have to buy a stack of servers to get my application up and ready. I can just rent them, right? And the cost is minimal for launching the stack of servers and basically getting them up and ready, right? I don't have to invest much. Even though I'm starting fresh, I've just launched my application. I don't need seed money for setting up an infrastructure, which is going to be huge for the whole world to see. Right? The whole world can access your application, but you don't have to worry about it because AWS is backing you up, right? So there is little or no investment. Second thing is more focus on app development. So you can focus more on app development than worrying about whether my infrastructure is fine or not. How is the traffic coming onto my app? Is my infrastructure scalable enough that it can handle all the traffic which is coming onto it? Everything is managed by AWS once you configure it correctly, right? Third thing is it requires less workforce. So like I said, if you are buying your own servers, you obviously have to have a team which is going to manage your servers for you, right? Any hardware upgradations, any security patch that you have to do, all of that is done by a team. Correct. But if you are launching your infrastructure or if you're creating your infrastructure on any cloud provider, the cloud provider's headache is to manage the servers. It's their headache to do the security patches. It's their headache to improve or upgrade the hardware once, the processors become slow. So all of that is managed by your cloud provider, and all you will do is focus on your app, focus on your business goals, and then succeed towards the goal that you have, right? So this is an advantage that you get when you use cloud computing, and that is why most of the companies today, so I guess only the companies who started out earlier, that is before cloud computing came into the picture, are still working on their own servers, hosting their own applications. But companies who are very young, who have just started out, for example, startups particularly, they prefer cloud computing or they prefer their servers to be on the cloud, because obviously when you are starting off with a new company, you have very limited amount of money that you can invest on things, right? So it's always a good idea to invest on the things which are required, and rest, if it works in a certain way that they are not costing you much, it works that way, right? So for startups especially, cloud computing is a huge thing. It's a huge bonus, and that is why you can see a lot of new business ideas are coming in. A lot of new people are trying out their own app or their own websites to provide a particular service. Reason being, the major part of starting up a business was setting up the infrastructure that is handled by cloud computing these days, right? And that is why you can see more and more young companies are coming up and they are trying out an app. If they fail, there was little investment investment involved in it, so it doesn't matter. And that is what is encouraging the entrepreneurs of this age. So guys, these are the advantages of cloud computing. Moving forward now, because cloud computing is so huge, there are a lot of products which are available on cloud these days, right? And you won't even know whether they exist in cloud or not. For example, Netflix is the biggest example that everyone is probably using every day in their life. The popular service Netflix, which is a movie streaming service, its entire infrastructure is on AWS. Everything from A to Z, the scaling part, the content delivery network, the networking part, the security part, everything is handled by AWS. Now, don't worry guys, if you don't understand the jargons that I just used, like content delivery network, security, everything I'll explain in this video. For now, I just want to tell you guys that because of the advantages that cloud computing has to offer, and because of the kind of services that you get from cloud, companies such as Netflix, Airbnb, Amazon itself are relying on the infrastructure of the cloud providers so that they never go down. Now, how did it come to these companies' minds to, switch to cloud? So I'll give you a very small example. Netflix suffered a huge blackout on the internet, I think in somewhere around 2008 or 2009, wherein all the services were down. Why? Because the more number of users came up to use the service, and that's when the servers crashed, right? The whole application went down, and it caused a huge loss to the Netflix company itself, right? And that is when they decided, dude, I cannot manage all my servers. I can either do the app development or I can manage the servers. There's only one thing that I can do. So then Netflix started to migrate itself on the AWS infrastructure, which is highly scalable, which is highly available, right? And now seldom do you see that, Netflix services down. In my experience, I've never seen Netflix down since I've been using it from the past 2-3 years. I've never seen Netflix down, or I've never seen an error that, the server is out or there's a problem with the infrastructure. I've never seen that, right? And that is because of the high availability that is provided by the cloud providers these days. Netflix is just one example. Other businesses that we are all aware of is the Amazon e-commerce website, right? The Amazon e-commerce website is also hosted on the AWS infrastructure, right? Now, a company, an e-commerce website whose bread and butter comes from a website, from being online, right? Imagine they are relying on the AWS infrastructure that all of you guys also have, access to, right? So imagine yourself, you're sharing the same infrastructure which the biggest e-commerce company in the world is using. So you can be rest assured that your application is in safe hands, right? Another great example of cloud computing is Google Drive. So Google Drive is a cloud product. The Google Documents, the Google Drive where you can upload all your files and folders, they're all hosted on the Google Cloud, right? And that is again a fantastic cloud product. Then we have Airbnb, which is actually a website which is hosted on AWS, and it's fully hosted on AWS for all its functionalities, scalabilities, and availability. Prime Video, which is video streaming service for Amazon, that is also hosted on AWS. And the funny thing is Netflix, which is its biggest competitor, is also hosted on the same infrastructure as Amazon Prime Video, right? Awesome, isn't it? So these were all the products that you see in your day-to-day life that are actually cloud products, and you wouldn't even know whether they were on cloud or not. So now you know. Moving further, guys, now let's talk about the cloud computing models. What are the different kind of models that in cloud that are there in cloud computing, and what are models exactly? So guys, cloud computing is basically divided into two kind of models. The first model is the deployment model, and the second model is the service model. So how do we get these two categories? The way you can deploy on cloud has 3 ways to it, and the way you can access services on cloud has again 3 ways to it. Right? So one is about putting your application out there. So if you're putting your application out there, you have 3 options, either to use public cloud, private cloud, or hybrid cloud. If you're using a service from cloud, you again have 3 options, which is infrastructure as a service, platform as a service, and software as a service. Let's understand all these things one by one. Don't get carried away with all the big words used here. We'll understand each and everything one by one, and then as you move along, if you have any questions, you can put it, right? So far, guys, I've not got any questions. I guess everything is crystal clear to everyone. So moving forward in the next slide, I'm going to start with the deployment model. So if you have any questions, now is the time, guys. You can ask me all out and I'll be happy to answer it for you. All right. So Shambhavi has a question and she says that Netflix is using AWS. So that means all the videos that we see are also hosted on AWS. Yes, Shambhavi, all the videos that you see, the software itself, the website exists on AWS. Okay, so she has one more question. But when I install the Netflix app, it's available on my mobile. How is that on cloud? Okay, so Shambhavi, there are two sides to it. Netflix application, it's basically a client application. The videos that you get, they don't exist on your phone. They're actually streamed from the internet, right? So your Netflix application is just a client application, but it interacts with the AWS servers on which the Netflix servers have been deployed. All the videos that you see, there's a service called Amazon S3. All those videos, they exist over there. They're stored over there, and they are basically provided to you using a content delivery network, which is basically nothing but a caching system. That is, I'll give you a very simple example that if you are residing, let's say in India, and you are watching, let's say, a US television show. So obviously that US television show is would be existing on the servers of the Netflix US, right? But if you are viewing in India, it doesn't make sense to stream all the way from US your video, right? So the server has to be connected through the internet from the US to the Indian client app which is existing on your phone. That's a long way, right? And that's when the concept of latency comes in, wherein how does an application respond to your queries also depends on how far is the server from your application, right? So there's a service called Content Delivery Network, which basically what it does is it caches all the videos that you have to see or you're watching onto an Indian server if you are in India, right? And that's when, a server which is nearer to you has all the content which exists on the US server. And this is all on demand, right? So this is just very simple, a very small thing that Netflix does to improve its service using the AWS infrastructure. And this concept that I just told you is Content Delivery Network. Don't worry if you don't understand what I just told you. As we move along, I'm going to explain this in detail. All right. Any more questions, guys? All right, so everybody is giving me a go. All right, guys, so if everything is crystal clear, let's go ahead and discuss the models one by one. So the first model that we're going to discuss is the deployment model. So what are deployment models? So guys, deployment models are nothing but the various ways using which we can deploy our application. All right. Now there are various ways. Let's look at those ways one by one. This is the first way of deploying your application on the cloud infrastructure is called public cloud. Now, what is public cloud? Public cloud is are the servers which are offered by your cloud provider, in which each server can have multiple companies hosting their application. All right. It could be your Netflix and it could be that your, its competitor, that is Prime Video. If you have offered for public cloud, your application would share the same server as some other application. It could be Prime Video as well. Right. So, but why is there a segregation? Although there is no problem when there are multiple applications on the same server, but what happens is some companies are still skeptics. Some companies have data policies that they say that, we have confidential data and we cannot take any risk where, some other companies also on our server and there's a risk of our data being hacked into, right? So that's why, because of these data policies, there were different deployment models that were created. So like I said, public cloud is when, the data that you're providing to the cloud is not that sensitive, is not that confidential, and hence you are okay when AWS tells you, although there will be no problem when a separate application is also deployed on the same server, there will be no harm to your data, and they say like, okay, anyways, we don't have any data policies like that, right? So public cloud is when you are using or the cloud computings or the cloud providers servers and you allow them to host more applications on the same server. You're okay with that fact. All right, so that is public cloud. Next is private cloud. What is private cloud? Private cloud can be two things. The first thing is, like I said, if you want a separate server all for yourself, where you say, no matter how much space is empty, no matter how much of the server is free, I don't want any other company's data on my server. I want my data to be isolated. I want it to be isolated on this particular server that you have in your infrastructure. So that becomes a private cloud. The second way of creating a private cloud is you buy your own servers and you create your own cloud in your data center, right? That is, you buy all the stack of servers required and you host your application as if you're hosting on a cloud provider. It's just that it's your own cloud that you have created, right? You have bought your own servers and you're putting your data on your own servers. So that is private cloud. Okay. So the third thing is hybrid cloud. Now, what is hybrid cloud, guys? When you want to have a kind of infrastructure wherein you are using some of the public cloud and some of the servers from the private cloud, in that case, it becomes a hybrid cloud. So let me give you an example. Let's say there is a research company. So that research company, the marketing website for that research company exists on the public cloud, but on that marketing website also people have the access to log in, and when they log in they can see their research materials that they're working on. Okay, but this research material, it does not exist on the server of the public cloud. It exists on some other server which is private cloud. So from a user's perspective, I will say that it seems that everything is on the same website, but actually the infrastructure is like this, that the private cloud is or your sensitive or your research files are basically on some other server, or let's say the private cloud, right? And the website that you're hosting, which doesn't have that much of confidential data, is actually hosted on the public cloud, right? So this is a fine example of how a hybrid kind of architecture is created. One more example that I can think on top of my head is that let's say there's a company wherein it's been there since the past 15 years, right? So they have some legacy systems that they don't want to touch, which they have bought and on which the application is working. But what they have decided now is that any of the servers that we are going to launch from now on, any of the new applications that we are going to launch from now on, we are going to launch it on a cloud provider server, right? So in that case, what happens is these servers which were there in your data center, they have to be on the same network as the cloud provider's servers, right? That is a public cloud, and hence that kind of a mixture or that kind of a arrangement again becomes a hybrid cloud. So guys, these are all the cases wherein you can, or these are all the ways you can deploy your application on cloud. So first we discussed public cloud, which was basically when the servers they can be shared between multiple clients of the cloud provider, right? And basically those servers are owned by the cloud provider. Second is private cloud, wherein there are two cases. The first case could be that you own or you ask your cloud provider to give you a separate server stack where no other data will be available, only your data will be available. That is one kind of private cloud. Second kind of private cloud is when you buy your own servers and you set up a data center and that becomes your own private cloud. That is also a way of creating a private cloud or using a private cloud. Third kind of deployment is a hybrid deployment, wherein you use some servers from the public cloud and you use some servers from the private cloud, and hence it's called hybrid. All right. So guys, any doubt in whatever we have discussed so far? If yes, please comment in the chat box or put your question in the chat box and I'll be happy to answer it for you. Any doubts, guys? If there are no doubts, we'll move forward. But if any doubts, now is the time that you can mention it and I'll clear it for you. Alright, so Shubham is saying, can you explain private cloud once more? Sure, Shubham. So private cloud is nothing but using a server which is not shared by anyone else, right? So how does AWS work, or how does any cloud provider work for that matter? They buy a very big machine or very big server with a lot of RAM and with a lot of processing power, right? And what they do is they launch multiple instances of virtual machines on it, right? So it could be that, you imagine your laptop, you can probably, if it's a i3 or it's a i5 with around 8 GB of RAM, you can launch around 3 operating systems on the same server at the same time using a virtual machine. right? You can do that. Now, similarly, what cloud providers do is they buy a stack of servers, and what they do is they launch multiple virtual machines on that server, right? And those virtual machines are owned by people who basically launch it through the AWS console or the Azure console or the GCP console, right? They launch it from there. Now, when your application or when your instance is up and ready, it is actually a part, or it's actually a virtual machine which is a part of a server. But it could be that that same server is hosting 7 or 8 more virtual machines which are owned by other people who have created their Azure or GCP accounts. Correct? So if that is the case, then there are some companies like let's take the example of government agencies, government secret agencies, which or intelligence agencies like CIA, or in CIA in US, like Homeland Department in US. All of them, they have very confidential data which have to be accessed by their internal employees, irrespective of the fact where they are sitting and in what part of the world they are sitting. Right now, in those kind of cases, what happens is, although they can buy their own servers, they can set up everything by themselves also, but then, like I said, they'll have to hire a team also that will manage the servers. So what cloud providers do is they give you an option of having your own server stack, which is isolated from the rest of the infrastructure of your cloud provider, right? That server stack is exclusively for you. It'll be a little higher, the price will be a little higher, but it'll again be on a pay as you go model. That is, you can say that for how much ever time you'll be using it, for that much time only, you'll have to pay the cloud provider. So that is what private cloud is, that you get a separate isolated server for yourself on which you will be working. You will be putting your applications on it, right? And those applications will nowhere be connected to nowhere will be sharing the infrastructure which the other clients of that cloud provider are using. So that is private cloud. Other way of saying what a private cloud is, that you buy your own servers and you set up in a data center, right? So although in that case you're not getting the benefits of cloud computing, but yes, that also is called a private cloud, because you buy the same kind of infrastructure, you buy the same kind of infrastructure at scale, at the same scale that a cloud provider does. You buy it at the same scale, right? When I say scale, in the same quantity, you set up a data center according to it, and it becomes your own private mini cloud, right? That is also what a private cloud is. So, all right, I guess Shubham, now you're clear with the doubt. All right, thanks, Shubham. So, others, if there is any doubt in whatever I've explained so far, please let me know. I'll clear it out. And if not, I will move forward to our next topic. All right, so everybody is giving me a go, guys. So great. Let's move on to a next topic, which are service models. So we have discussed deployment models. That is what are the various ways in which I can deploy my application on a cloud provider. Now let's discuss the various kind of services that I can get from a cloud provider. Okay, so let's discuss that. So what are service models? Now guys, there are 3 kind of service models that we get in cloud computing. The first one is infrastructure as a service. Now what is infrastructure as a service? Basically, the cloud provider will give you an access to the server. That is, you will get an access to the operating system of the server, and you can install anything you want in that server, and that will become, it can either become a database server, it can become a website server, it can become anything. So basically, when we say infrastructure as a service, you're getting the whole infrastructure, you're getting the whole system, you're getting the whole virtual machine as a service delivered to you. Right? So that is infrastructure as a service. Second is platform as a service. So in contrary to what we got in infrastructure as a service, wherein I got a machine that I could use, in platform as a service, I do not get the access to the operating system. Okay, what I do get an access to is kind of like a dashboard, wherein in that dashboard I can upload any files that I want, and those files would automatically be put on the server by AWS, and I can see those files hosted on the server. If it's confusing, let me give you an example. Let's say if I want to set up a website, and what I get is infrastructure as a service, So in that case, what I'll have to do is I'll get a fresh operating system. On that operating system, I'll have to install a web hosting software like Apache or Tomcat or anything. Once I have installed it, I will have to do an FTP, or I will have to transfer my files from a local computer on that AWS server using FTP. Once I've done that, I have to put those files in a specific folder on that particular server, and only then I will be able to access it when I go to the IP address of that particular server. This is the case of infrastructure as a service, where I've done everything that I had to do, right? In case of platform as a service, what happens is that I will not get the access to the operating system. All the softwares, all the settings that are required to be done is done by AWS. What I do get an access to is a dashboard where I have a button called upload. I click on that upload button, and what it'll do is it'll upload my website automatically. It will directly upload it to the location where it has to be. It will give it the required permission so that my website is hosted. So as a user, I don't have to get into the nitty-gritties of what kind of software has to be installed, what version of software has to be there. Everything is managed by AWS. I just upload my website and my website gets up and ready on a particular IP address. Okay, so this is platform as a service. It's basically an automated version of infrastructure as a service, where you get specific access on the server that you can just upload your files. There is nothing else that you can control on that server. That is platform as a service. The third kind of service that you get is software as a service. Right, what happens in software as a service is that, in contrary to what you got in infrastructure as a service, wherein I did not get access to the server, or where I got access to the operating system of the server. I could install anything, I could make that server anything, right? Second thing was platform as a service, where I got a dashboard where I can still upload my files, and those files will be hosted for me. Rest everything else will be managed by AWS or the cloud provider on which I'm taking this service from. Third kind of service is software as a service. Now, what is software as a service? You do not get access to a dashboard where you can upload your files. You do not get access to the server where you can do whatever you want on the operating system. What you do get is a software which has already been hosted on the cloud, and that software you can use. The straight away example for this would be Netflix. So Netflix is a software, correct? It doesn't matter which server it is on. It doesn't matter whether you can upload your files or not, but you can use the software which is hosted on the cloud. That is software as a service. Software has been provided to you by the cloud provider to use as a service, and that service is a pay-as-you-go service wherein you'll have to do a monthly subscription. Okay. Another example for this could be the Google Docs that you use. You use Google Excel, or you use Google Word, right? All of those are softwares which are hosted on the cloud provider, and you can use those softwares. It doesn't matter which server it exists on. It doesn't matter what kind of softwares are installed on that server. I just have one software that I can use, and it has been hosted on the cloud. So that is software as a service. All right. So this is all about the different cloud models which exist, which are offered to the customers, right? Moving forward, now let's talk about cloud providers. Now, whatever we have discussed so far is in general, or is generic to cloud computing, right? Now, these kind of models, or these business models that we just discussed, have been adopted by various companies which are out there. Right, so companies like AWS is there. This is the most prominent one. Second is Microsoft Azure, and then you have Google Cloud, and there are 100 plus more companies which give you the same kind of services. Like another famous cloud provider which comes on the top of my mind is DigitalOcean, which is there, right, which offers the same services, just that the jargons that it uses for giving you that service is different. The terminologies would be different, but at the back end, it's doing exactly the same thing, right? So DigitalOcean is there, Joint is there, Telemark is there, IBM Cloud is there. There are a lot of cloud providers. But why have I just showed you these three cloud providers? Because these are the three top cloud providers in the industry right now which give the cloud services. Okay, I'll say 90% of the whole cloud paradigm is actually covered by just these three cloud providers. That is, people, if there are 100 people who are using the cloud computing in the world, out of them 90 people would be using a service among these three only. Okay, now today in this session we are talking just about AWS, but why are we only talking about AWS? Why are we not talking about the others? Let me walk you through the points. So guys, the number one reason for AWS being so popular is that it covers 35% of the market share that is using the cloud computing platform these days. That means that if there are 100 people who use cloud computing, or if there are 100 companies which use cloud computing, out of them 35 companies would be using AWS, right? So that's what the 35% market share means. Second reason is that AWS was way back incepted in 2006, and since 2006 I think it's been 13 years. So since 13 years AWS has been running the cloud computing business, and when AWS launched its cloud computing business, I guess it was the first and foremost cloud provider which went into the cloud computing domain and thought, okay, I can run a business on it. I guess back then there was no company which was providing the cloud computing services except AWS, and that is the reason, AWS has such a huge market share, which is 35%. If you compare it with Azure and Google Cloud, Azure is at 13%, and Google Cloud is at 6.5%, right? So Azure is a number 2 cloud provider in the world, and Google Cloud is at number 3. So you can just judge by the distance between this 13% and 35% that how huge AWS is, right? And Microsoft Azure has to do a lot of catching up to basically beat AWS right now. And the point that I'm trying to make here is that the reason for that gap is because AWS was launched way back in 2006, and Azure was, I guess, launched in 2012, followed by Google Cloud in 2013, right? So that is the reason most of the companies were already on AWS when Google Cloud and Microsoft Azure came into the picture, all right? So Microsoft Azure has 13%, Google Cloud has 6.5%, AWS was launched in 2006, and that is the reason AWS has a more mature model of infrastructure. Now, why is that? Because any company or any product that you launch, it always has, so when the first time when it's launched, it always has a lot of bugs to it, and it's as and when the companies or your clients start to use it, you get to know, okay, so this is also a problem, this is a problem, this is a problem that you have to solve, right? And when you solve it, your product becomes more mature. It becomes more reliable. And since it's been 13 years now that Amazon has been in the game, it has matured a lot. And when we compare it with Google Cloud or Microsoft Azure, they still have a long way to go. Already, although they have launched pretty good products, but they still are no match to what AWS has in terms of reliability. And that is the first and foremost reasons companies also have, they stick to AWS as their first choice, because most of the companies that they see, like we discussed, there is Netflix, there is Airbnb, there is Amazon e-commerce company, then you have Prime Video. All of them are on AWS and they're doing well, right? None of them has experienced any downtime being on the AWS platform. So any company who is trying to launch their product into the market, they also stick to AWS, reason being it's so reliable. Third reason that why we are learning AWS today, why you guys are learning AWS today, is because of the job opportunities. So because it has a greater market share, because there are more companies who are using AWS, obviously the job opportunities for AWS are also more, right? When you compare it with its counterparts, that is Google Cloud and Microsoft Azure. So like I said, if there are 100 companies, and out of those 100 companies, if 35 companies are using AWS, that means 35 companies you can apply on to become a solutions architect, to become an AWS developer, to become an AWS administrator, a cloud engineer, anything, right? So it's always better if you want to get into the cloud domain to first get to know the major player, right? And then obviously you can also learn Microsoft Azure. Once you have understood AWS, it's very easy to actually understand the other cloud platforms like Microsoft Azure and Google Cloud, because they're almost the same. All of them are basically giving the same services, just that the jargons or the terminologies that they use are a little different. Alright, having said that, guys, let's move on. And now that we know that why AWS is so successful, we understand that why are we learning AWS today. Let me introduce you to what AWS is. So guys, AWS is basically a subsidiary of Amazon.com, which is basically the largest e-commerce company in the world, right? So the way AWS came up in the market was that Amazon, the largest e-commerce company, was building the infrastructure for its website, right? And they designed an infrastructure which was highly scalable, highly available. It can auto scale itself. It can, downscale itself. So all of these things were part of their architecture of the Amazon website. Now, when they created an infrastructure like this, they thought, why are we only using it for our website? Why don't we make it available to the general public? And they can use it as long as they want in a pay-as-you-go model. And that's how the cloud computing model or the cloud computing business came into the picture, right? So the same infrastructure that it was using for its website, it made it introduced to the world to say, like, I'm hosting my website, or I'm hosting my Amazon e-commerce website on this infrastructure. If you also want your application to be as successful, as reliable, as available as my website, you can use the same infrastructure. And you know what? You just have to pay for the time that you used it, and the cost is as low as $0.0005. Isn't that amazing? So that's how AWS came into the picture, right? And now today it offers services in compute, it offers services in storage, networking, management, security, and many more that we're going to discuss as we move along. All right. So this is the AWS story, guys. We understand now that what is cloud computing. We understand now that the different kind of models that cloud follows. All of those things are followed by all the cloud providers. AWS is one of those cloud providers, and I told you the backstory of it, how it was launched, how it was incepted, and since it's the first player which came in the market, it's very matured in terms of its services. I think they have covered all their edge cases as to how our application can actually not be of use to a particular company or can fail, and they've covered all that. So you can be rest assured that if you are deploying an application onto AWS, it is in safe hands. All right, moving forward, guys, now let's talk about the thing that we are here to learn for. Let's talk about the AWS services. Let's see what kind of domains does AWS gives its service into. So AWS provides its services in compute, it gives in storage, database, security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? Alright, Shubham, so storage is basically used when you have a workload wherein you want to upload binary files. Like, what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right. So all your videos, all your music, right? Any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or we have one kind of database service for that. If you have unstructured data, you have another database service for that. but we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you're using, to the account that you're using, for all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as you move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain. Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Autoscaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS management console. Like for example, autoscaling would not be under the compute domain. It would be under some other domain. I'll show you when we move on to the AWS management console as to where you can find each and every service. For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch, and what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well. Right? So guys, Elastic Cloud Compute, like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything. You can make it anything. You can basically build it, make it a web server. You can make it a database server. It can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it. And then you can launch multiple copies of that particular EC2 instance so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also do that, right? Let's say if my RAM was 8 GB over here and then I want to make it 16 GB, even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, that is EC2, right? Our next service is Elastic Beanstalk. Now, Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2 and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go on to the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, you don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy and upload your website over there. That's it, right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that. Because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image. And what that website does is it stores the image on its storage and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result on the website. So basically only processing happens on AWS Lambda, only website deployment happens on Elastic Beanstalk, right? And AWS gave us these two wonderful services so that we can create a distributed kind of an architecture wherein, there is no fault. If there's a fault in one server, it's not like my whole application will go down. I have certain redundancies in place. I have distributed my work among multiple computer nodes so that even if one gets faulty, it's not like my application will go down. We'll discuss more on this as we move along and we talk about auto scaling. But guys, remember this, AWS Lambda is only used to run your background code. AWS Elastic Beanstalk is only used to deploy a web application. EC2 can be used for anything. It's your own private computer. You can install any software, make it a backend server, make it a web application server, make it a database server for that matter. Do anything with it, right? That is what AWS EC2 is. Now, if you see the diagram over here, as you can see that, let's say there's an e-commerce application, right? And that e-commerce application, there's a trigger for basically buying something. Let's say you order a package, right? So when you order a package, what happens on Amazon? That entry is made into the database. So that entry is stored, let's say, in DynamoDB, which is a kind of database in AWS, right? Now what happens? Now, once the data is stored in DynamoDB, you want to do some processing on that data and then go ahead and store it somewhere else, right? So once the data has been stored in DynamoDB, I need the processing to be done. Now, the one way to do it is you do everything on the same server, where basically, let's say my package order confirmation happened on the web application, right? The web application server triggered this particular action that I have, my package order is confirmed. And that's when it issued a command to store the data in DynamoDB. That is all done by my web application server. Now I can also, this server itself can also do the processing for DynamoDB and then store it on Redshift warehouse. But the processing takes a lot of time. And that is the reason I differentiate my processing on a different server, or I make my processing happen on a different server so that there is no overhead on my website, so that my website is not becoming slow irrespective of the fact that what kind of workload is running in my backend. Because that workload is being managed by AWS Lambda, right? So my website can be up and running. It will always be available to all the users irrespective of the fact how huge of processing I have to do, right? So that happens by AWS Lambda. One more thing, guys, one more cool thing about AWS Lambda is that whatever job you give to AWS Lambda, it's not one server which does the job. AWS Lambda takes a job, executes it in one server. If it gets one more job in the meanwhile, what it does is it launches a second server on which that job will be executed. Similarly, if there's a third job which is coming, it will be executed on a third AWS Lambda server. So that's how it works, right? And once the processing is done, it can also give the communication back to the web application, and that's how you get the message that the operation is done. But what you don't understand is how many computers or how many servers are working in the backend, right? So now you know. So AWS Lambda, wrapping up, guys. So AWS Lambda is used for executing a backend code. AWS Elastic Beanstalk is used to deploy a web application. And AWS EC2 is a raw server which you can use to make that server anything, right? It could be a web application, it could be a backend server, it could be a database server, etc. Our next service, guys, is load balancing. Now, what is load balancing basically, and why do we need this kind of a service? Now, guys, I told you that whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies so that my application is highly available. Now, what does that mean? Imagine these three servers are your web application servers. Now, if you just had one, imagine you just had one. In that case, what will happen? If there is any kind of fault in this particular server, my application will go down, right? So what I do, I launch 3 exact copies of that server, right? And what happens in that case is if this server goes down, my user can view my website on this server. If both these servers goes down, my website can be viewed on this particular server, right? But now you might be wondering, how will the user know which server to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the three servers are functioning in the healthy state, in what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what autoscaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is, at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your autoscaling group, right? And that's how it works, guys. And the autoscaling service cannot exist alone. It always has to work in conjunction with AWS load balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of autoscaling, you will always make use of AWS load balancer. On the other hand, you can just make use of AWS load balancer and you might not want to use autoscaling. That is fine. But if you're using autoscaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what autoscaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry, guys, if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS. So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now, don't get confused, guys, with what we do in EC2. Now, you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an auto-scaling infrastructure. That is a machine on which Docker is running. But if the processing or if the CPU gets an overhead, and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know, guys, what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat -test, right? We'll click on continue. Then it'll ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? It's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address that through which you want to connect. One second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right. So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. All right. Now, what we wanted to do was we wanted to launch our first server, and for that, there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2. So I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that. And now this link would basically open your EC2 dashboard. Right? So from here, you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance, and for that you just have to click on this blue button which is here which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. You have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay. So let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from. Right, but the only server that is free for you would be t2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select t2.micro if you want to be under the free tier and not be charged. So just select t2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this this instance belongs to is this. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule, I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is a message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being in launch. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test-Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's the software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your putty software. Right, this is my putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH, then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it'll give you a message that this server host key is not cached in the repository. Just click on yes on this message and now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it'll verify the key that I inserted and it'll be able to connect to the putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay, so you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this. Right, t2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right, so let's name this instance as Windows. All right, and now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect. And this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator. And if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch. But this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here. Right, once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember the PEM file will work and not the PPK. Let's click on open and now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes and now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk? Right. So as you can see, it says welcome to AWS Elastic Beanstalk and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET. I can put my web app in Go. I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these are all the settings that you have to do guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it and only then I'll be able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy and just I have to choose a file, click on deploy and that website will get deployed automatically over here. I will just go to this link, refresh it and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. All right. So when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, fire assist, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess, hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Autoscaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file, is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application, can still be working. Okay, so Amazon S3 is a file storage system by AWS, which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that, you know, your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, you know, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service, and for that I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists. You can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket, and you will be able to host static websites in that case. All right. Our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service, and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that, there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS, and you feel that you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture, where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed first was under storage, which was S3. So let's click on the S3 link, and that will give you UI, which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures, and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3, you want to archive the data, put it in Glacier, all those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here, right? Now, if I select this file, I can actually see the properties of this file via this link, right? Here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website, and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS management console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances, right? Now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is a security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking. You'll go to actions, go to networking, and click on change security groups. So as you can see, it is only launch wizard 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command, and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command, and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let's the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command, and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do an ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server or the server from which the information is being requested. What happens is, let's imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens? Your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS management console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now, what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now, what is an application account? Let's say I have a website which can upload data to S3. Now, how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise, it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means key management service. So key management service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. All right, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation. Then we have AWS OpsWorks. Then we have AWS CloudTrail. And in the end, we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay. So let's say I have launched two EC2 instances with a load balancer with in an auto scaling group, which is connected to an RDS instance, which in turn is also, connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region, I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together, they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say, MySQL on, let's say, 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now, don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so, and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture, and then in that case it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening, and it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it, and then that log data basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now, what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure will take very less time to just configure my CloudWatch to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay. Moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, you'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called simple notification service and the other one is simple queuing service. Let's see what these services are. So the first service, which is Amazon simple notification service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay. So based on the topics, the messages are filtered, and what you do is in the topics, you will define which service to basically trigger. And based on that, those services will be triggered, and the services to be triggered are basically called subscribers. Okay. So guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay. What it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to that to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So for I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay as you go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get for instance is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right. So that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in. And in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances, all of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price, but up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now it is particularly helpful for people who are trying out AWS or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right. So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you're running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect the service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free, and the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like. So let me jump on to my browser. Right, so guys, my website basically exists on localhost/new. Right, so this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once a entry is made inside the database. Second thing is, right now, if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here, what I'll do is I will create a user, right? And let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now, the kind of services that I want my website to access is only S3, right? So let us put an S3 over here, and as you can see, there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user, guys, I will have the access key ID and I will have the secret key, access key. Now, this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID, guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like, guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket, right? Which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is, the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now, what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, there's test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this, this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database, and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it will ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only the instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Alright, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit, right? So this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry, guys. I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket, and this remains the same for each and every object which gets uploaded, right? So I'm uploading, I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website, right? So if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right. So once I've done that, it works great. It works like it is supposed to. Now, I guess we should go ahead and check if my RDS is ready. Yes, guys. So my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my localhost. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for their security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my localhost. So the table name would be names, and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is, let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. Alright, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select star from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great, guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk, guys, and this is the dashboard that I get when I use the platform as a service instance. Right now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here, guys, is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said, and whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great, guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database, which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if you go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that, guys. And it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it. All right. So thank you, guys. I think this is it for this session. Let me just come back to my slides. All right, so thank you guys for attending this session. I hope this session was useful to you. So I have showed you a pretty good hands-on, which I would request you guys to practice. So this code will be available in your LMS. So I would request you guys to go in your LMS and download this code and try it out once on your machine as well, right? For setting up PHP on your machine, all you have to do is there is a software called WAMP. If you're on Windows, just download that software and install it. Just put that code file that you will get from your LMS in the www folder inside WAMP64, right? Once you put it there, you go to your browser, go to localhost / the folder name that you have named where the code files exist, and then you would be able to use the website, right? Mind you guys, you will not be able to see any files on the list.php page. Reason being, you will have to connect your own database and your own bucket to make the code working, right? So I'll comment on the codes wherever you have to add values. You can add those values and your website will then be up and running. All right. So thanks a lot for attending this session, guys. Have a great day ahead and good night.